right, so let's look at yet another one where we have the numerator degree less than the degree of the denominator. So again, we'll go into the partial fraction decomposition. So we've got factor the denominator, which is t times t minus 4 on the left side. So the right side, what do we do for the right side? Well, we put a over one part, a over t, and then b over the other part, the other factor of the denominator, t minus 4. And then essentially, we're multiplying both sides by t times t minus 4. So this side will just be 8. What about this side? Well, the a times the t minus 4, the t's are going to cancel, so it's going to be a times t minus 4. And then the b, what would be b times by? Well, the b's got t minus 4 denominator, and so that'll cancel out, so it'll be b times just t, bt. All right, so said there's different ways, but a little shortcut method is, see if you can get one of the things to cancel out using a certain t value. In this case, looking at this one, t equals 4. All right, so if t equals 4, what do we got? Well, this side's still a, because there's no t with it. This side would be a times 4 minus 4, a times 0, and then this side would be b times 4. Yeah, so that's going to zero out the a there. And we have 8 equals 4b, so again, b is 2. Yes? So we got our b value. What about the a value? Well, to get the a value, let's look at the b. T equals 0, right? If I choose t equals 0, then I wind up with 8 equals a times negative 4, right? Because the t is 0 in this second case, plus b times 0. Zeroes out the b. So we got negative 4a equals 8. It looks like a is negative 2. Yeah. So really quite similar. Similar deal there. So our integral now becomes then what? This 8 over t. I can rewrite now the 8 over t squared minus 4t, which is this, as a over t, so negative 2 over t, plus b over t minus 4, so it's 2 over t minus 4. And again, those are very simple. That's just negative 2 times the ln of the absolute value of t, and that's positive 2 times the ln of t minus 4. Let's just see. Really not too bad. All right, so a couple of things that we can encounter. So those are fairly straightforward ones. They might throw in a few of those, right? If we're lucky. But what else can happen? There we got this one? Yeah. All right. Here's what else. Integral of 6x plus 7 over x plus 2 squared dx. All right, first of all, it's basically already factored. I mean, we saved that step where you have, it could have been written x squared plus 4x plus 4, but it's already kind of factored out for us. But the difference, what's the difference here in what I've got here compared to those other previous examples where I use this partial fraction decomposition? I've got a factor squared. And so that's a signal. Something's a little different here about this. So when you got a factor squared, here's what you have to do. Turns out a squared factor, you're actually going to need, for each squared factor you have, you're actually going to need 2. You know, before we just put, if we had 2 different factors, you just put 1 of each, right? Denominator. Well, it turns out if you have a squared factor, you need 2 factors, 2 different terms for it. And so in this case, I am going to have 2 terms, even though it's just x plus 2, but it's squared. You with me there? So if you have a squared factor, you need 2 different terms here, parts, I guess better. All right, so I'm going to need an a over x plus 2. But then the other one is not b over x plus 2, because that would really do nothing at all for us. You thought through it there. No, the other one I need is b, not over x plus 2, but over x plus 2 squared. And so it probably makes sense, I should, since there's really 2 factors there, I need 2 over here, but it may not seem obvious why we do that, but it will work out. We do it this way. So you see what difference here? So that's what you do if you have a squared term. All right. So let's see what happens if I do that. So what do I multiply by here? Well, it's going to be x plus 2 squared. So multiply by all parts there in the equation. So this side, well, the x plus 2 squared are going to cancel out at 6x plus 7. Now when I do this one times that, what's the a going to be by? Multiplied by. But one of the x plus 2's go out, so I will have an a times just x plus 2 on it. Now what happens here on the b? Well, the b is just going to be b, right? Because the x minus 2 squared cancels out, that just leaves me b. Okay? With me there? Question? Well, all right. Use our same little trick. What do you want to choose x to be here? -2, okay. Let's let x be -2. So if x is -2, that makes it -12 plus 7 equals a times 0 plus b. A zeroes out, so we're in good shape because we got b right there. -5 is b. -5 is b. Now, we kind of run out of things there now, don't we? Because there's no way to make the b term go away, if you will, because there's not an x here, so there's not an x value I can choose that would make b 0. However, since I now know b is -5, what's stopping me from saying that's -5? So I've got 6x plus 7 equals a times x plus 2 minus 5. Well, now, if I let x be a number, I can figure out what a is, can't I? Let's let x be 0. I mean, we could do x is 1, x is 2. Let's do x is 0. Makes that a 7 equals a times 2 minus 5. I mean, it's not as easy as those others, but that's not that hard of an equation, is it? Add 5. You got 12 equals 2a. So a is 6. So it's kind of an altered way of doing it. I mean, we can't do it quite the same as we did in those previous examples, but it's just about as easy. It's not that bad. All right? Now, here's the other thing. the integral part of this turns out to be a little different too. Let's see what happens. All right, so what we're saying then, let me go. All right, so we've got 6x plus 7 over x plus 2 squared. Yeah. So now we can rewrite this integral as a over x plus 2, so it'd be 6 over x plus 2, plus negative 5 over x plus 2 squared. Isn't that what, yeah, that's what a is 6 and b is negative 5. So now that integrals that. Well, the first one is, it's an ln. Simple ln. 6 times the ln of absolute value of x plus 2. But let's think about this one here. What do you got there? That's not an ln, is it? It's actually, I might say, even simpler one than an ln. All right, what if I wrote it this way? 6 ln of absolute value of x plus 2 plus the integral negative 5 x plus 2 to the negative 2 power dx. That's just going to be power rule with a little U-substitution again, but it's really a simple U-substitution because du is dx. If you go all the way through it here, see what I'm saying? If I let u be x plus 2, then it's just negative 5 u to the negative 2 du. That's, like I said, just a simple power rule. It'd be minus 5, then it would be u to the negative 1. Just have to divide by negative 1, right? So I've got 6 ln of absolute value of x plus 2 plus 5 u, but u is x plus 2, the negative 1. Let's see. Yeah, so that, since that was x plus 2 squared in the denominator, it wasn't an ln, but it was just a power rule. Antiderivative. Not too bad. Let's see. All right, so let me do another one, another one of these, just to give you another example that we can go through. That squared factor. And I think they're usually pretty nice. If they've got a squared factor, usually they give it to you factored form. They don't make you factor these big long monstrosities. See how this works. All right, so we got 36, integral of 36 over x plus 5 squared times x minus 1 dx. There we have another squared factor. So when we come to the partial fraction decomposition, what do we need? Well, we got x plus 5 squared, so I need an a over x plus 5, and I need a b over x plus 5 squared. But then I also have another factor of x minus 1, so I need a c over x minus 1. So this one turns into 3 different parts. With me? Yeah, so I got that squared, so it needs 2. All right, so I multiply through by that x plus 5 squared times x minus 1. and that times that would be 36. All right, then that times that would be what? A. Well, we've got an x plus 5, so one of the x plus 5s will cancel on the a with the a, but it'll still leave me an x plus 5 times an x minus 1. That's what a would be times, yes? X plus 5, x minus 1, with me? All right, then this times the b over x plus 5 squared. Well, it works better because the x plus 5 squared cancels out. And so I have b times x minus 1. And then last but not least, this times the c over x minus 1. The x minus 1's canceled, so I have c times x plus 5 squared. That look okay? So hopefully getting to that is not too bad. All right, so now we've got at least 2 x values that'll be fairly nice, I think, hopefully. X is -5, try it first. So that'll give us 36 equals a times 0 times -6 plus b times -6 plus c times 0 squared, but that's going to zero out the a and the b, isn't it? I mean the a and the c. So that'll make it 36 equals -6 times b, so that's b is -6. All right? So let's go with the x being 1. See what that does. X is 1. It's going to make it 36 equals a times 6 times 0. So that's going to be 0. And then b times 0. And then c times plus c times 6 squared. That's going to work out pretty good, isn't it? That's 36 equals 36c. It looks to me like c is 1. Sound good to you? So we wind up getting b and c. We still need a, though. How you going to do that? Well, again, we've run out of ones that would make a factor 0, an x value that would make a factor 0. So that's where we kind of use the altered form here. See if I can finish it up right here. So I now know the b and the c value. So let's rewrite that with that in mind. So it'd be 36 equals a times x plus 5 times x minus 1. And b is -6, so it'd be -6 times x minus 1. And then c is 1, so it'd be plus 1 times x plus 5 squared. Yeah, so if I do that, then I can just choose another x value beside, using -5 and 1 is out, but some other x value besides 1 or -5, and I can figure out what a is. What do you want to let x be? Is it anything? 2 maybe? X is 2? Because that would make that 1. I mean, it's just, it doesn't matter really which x value you pick. Pick one that kind of, I'm going to choose x is 2. So that'll give us 36 equals a times 7 times 1 minus 6 times 1 plus 1, and that'll be 7 squared. Yeah, I should be able to find an a off of that. So that's 36 equals 7a minus 6 plus 49. Oh, that's going to work out pretty good. It's 36 equals 7a plus 43. So if I subtract 43, I got -7 equals 7a. -1 and 7. There you go. So I got the A, got the B, got the C. Is that good? All right, so let's do a little calculation, evaluation of my integral here. So the integral 36 over x plus 5 squared times x minus 1 dx is now the integral of a over x plus 5, so it's negative 1 over x plus 5, plus b over x plus 5 squared, so it would be negative 6 over x plus 5 squared, plus c 1 over x minus 1. Again, the first and the last one, what do you see there? ln. So this is negative ln of absolute value of x plus 5. This is plus just ln of x minus 1, the absolute value. And then this one, well, that one's like the one we had on that last problem. Negative 2 power. Yeah, that's just going to be power rule. You can go through it if you want to, but it's going to be negative ln absolute value of x plus 5. That'll be minus 6. That'll be x plus 5 to the negative 1. That would be divided by the negative 1. And then, of course, that's plus 6 here. The only thing, do you see what else they might do as far as an answer goes for this to kind of condense it? What can I do?
Multiply.
Yeah, I can make those ln's be 1. I don't think I did it on any of the others, but they probably, in the answers, would condense that. You've got an ln minus an ln, so they would come together dividing. So it'd be the ln of, that one would be on top, that would be on the bottom. Because it's technically that minus that, plus 6. And they would probably rewrite this as this, right? But, you know, if you get there, you know, make that a plus 6. But if you get that, this, plus 6, plus 7, I'm okay. But just FYI, okay. Any other thoughts or concerns on that? Got one more to show you. What else could happen? Well, a lot of things, but here's the other thing I'm going to show you. Okay, so we got the integral 4x squared plus 8 divided by x squared plus 4 times x minus x plus 2 dx. 4x squared plus 8, and then the denominator is x squared plus 4 times x plus 2. All right, what do you notice different about this one? Yeah, that's not a x plus 4 squared, and it doesn't factor either. If it was x squared minus 4, then I can factor it, and they may throw those at you, but this is x squared plus 4. Sum of squares, you can't factor with the integers anyway. With real numbers. Yeah, so that's an irreducible factor. I mean, even though it's not a linear factor, it's irreducible. So that's the difference here is we've got an irreducible factor that's not a linear factor. A nonlinear, irreducible factor, to put it technically there. You with me? See what's different about that? Nonlinear, irreducible factor. Well, that does complicate it a little more. All right, so let's see what that does. So we've got 4x squared plus 8 over x squared plus 4 times x plus 2. What do we need? Well, good news is I just need one term or one expression over here for that. However, on top of that, it's not just a. That's what makes this different. Above an irreducible, nonlinear, irreducible factor, what I need to put, so if it's x squared plus 4, what I need to put with that is ax plus b. Ax plus b. If you got that. So if it was x squared plus 9, or if it was 2x squared plus 9, you still need the same thing, ax plus b. That's what goes over an irreducible factor. I guess technically we should say it's the second degree, but I don't think they'll get any more complicated than that. All right, so that takes care of that one. So guess what else I need then? For this one, then I would need c over x plus 2. Okay? All right. Let's see what this gets us into. So if I multiply, what am I going to get? 4x squared plus 8 equals, so it'll be ax plus b, what will they be? 5 times 5. Dx plus 2. And then the c, it will be multiplied by x squared plus 4. All right. So our little trick will get us accomplish a little bit here. Let's see what else we have to do. All right. X is -2. That'll get us somewhere, won't it? Four times 4 would be 16 plus 8 over here. X is -2, so that'll be -2a plus b. Oh, but it's times 0. So that really doesn't matter. Plus c times, what was that? -2. So it'll be 4 plus 4, 8. 8c. So I've got 24 equals 8c. Because this is 0. 3 is c. But I'm out of trick, all right? Because there's not one that's going to make that 0, because you'd have to go into imaginary numbers, and that won't help us on the others here. So, all right. So let's. So if I can't do anything else, 0 out. Let's just put in the 3 is c here. So we've got 4x squared plus 8 equals ax plus b times x plus 2. And our c is 3. All right, well, like I said, at this point, sometimes it could make a difference what you choose x to be, but it really doesn't matter a whole lot, other than it's got to be something other than -2, something we've already tried. So, looking at that, what would be your choice?
-2i.
No.
Yeah, imaginary wouldn't help, okay? We don't want to go there. We don't want a -2i plug in. No. Let's go simpler here. How about x is 0?
Yeah.
Since we haven't used x is 0 yet, let's use x is 0. All right, so x is 0. Thus, beside of 8 equals b times 2 plus 3 times 4. Oh, that's pretty good, isn't it? That did good. So 8 equals 2b plus 12. -4 is 2b. B is -2. Now we got 2. Okay. All right. So we've got 4x squared plus 8 equals 8x minus 2 times x plus 2 plus 3 times x squared minus 4, x squared plus 4. So plug that negative 2 in for b, and maybe we can figure out a if we choose another x value, not an I. How about 1?
Yeah.
X is 1. So that 4 plus 8 equals a minus 2 times 3 plus 3 times 5. Right? Is that right? So we got 12 equals, let's go into street 3, equals 3a minus 6 plus 15. So I've got 12 equals 3a plus 9. Subtract 9, so I've got negative 3 equals 3a, so a is negative 1. Ah, got A, B, and C. Now we're in shape.
Negative 1.
Huh?
Positive 1?
Oh, just checking. A is positive 1. All right. So let's see what that gets us into. All right, so here we've got the integral now 4x squared plus 8 equals ax plus b, so it'd be x minus 2 over x squared plus 4. Plus c over x plus 2, so it's 3 over x plus 2. Yeah, so I think we're where you were thinking might happen. We were going to get some complicated stuff. It's not real complicated, but we can run into something like this for these irreducible factors like this. So we're good here? We got that? Because I'm going to need more space here. It's going away. All right. Okay. No problem. Ln. This one a little more here to that. We haven't. So let's just this is easy, but let me write them out and then I'll do them all sort of at once or close to. So I've got to think of those two. This one. Okay, so we've got here's what we're going to do on this one, okay? You know, we've already done the partial decomposition, so it's, and I guess you could have think of it as something else here, but because this is what we're going to have to do usually on these. We're going to break this up into 2. We're going to break this one up into 2 fractions, which I guess we could have done here. We could have done ax over x squared plus 4 plus b over x squared plus 4. Whether that would make it easier or not, but that's what I'm thinking here. I'm just going to break this up. It's actually going to be the integral of x over x squared plus 4 dx minus the integral 2 over x squared plus 4 plus, if you want to do it that way, plus negative 2, doesn't really matter. And then the easy one here. Actually these are all going to be easy. All these are pretty easy, believe it or not. First one's probably the most complicated. of the bunch. But do you see how the first one's going to work? I've got an x squared on the bottom and an x on the top. First thing you should always think about is U-substitution. This is a U-substitution. U equals x squared plus 4. The reason it's U-substitution is because the du then would be 2x dx. And isn't that going to go nicely? Divided by 2. Isn't that going to cancel nicely? Yes. All right. So we have the integral of x over u, and then we have du over 2x. Yep. That's going to make it 1 over u du, which is ln. So that's 1 over u, well, it's 1/2 times 1 over u, which 1 over u is ln. Yeah, the other two are easy. We know the last one's easy. What about that second one? What is it? That's an arctangent, isn't it? Yeah, if you go back to the, I didn't bring my little formula sheet, but on that formula sheet, what do we got? You got 1 over a squared, integral of 1 over a squared plus x squared, that dx, that equals 1 over a, tangent inverse x over a plus c. Isn't that what we got here? Except it's not 1 on top, it's a -2, but the number doesn't, on top doesn't really matter, it's just a number. This is -2 times, all right, so it's, well, it's a squared plus x squared up here, so this is x squared plus a squared. What's the a?